This video covers product of powers. Please be sure to take notes on the paper that you were given in class. Thank you. So that you can participate in the stations on the following school day. The first thing we're going to go over are the top of the notes, where it says product of powers. It reads, for any number A and all integers m and n, a to the m power times a to the n power will equal a, and we're going to write the rest in, m plus n power. That's the actual law or rule. Sometimes we call these laws of exponents. Sometimes we call them rules of exponents. Now, before we get started in detail, I want you to add a couple of things to your notes. The first thing is we're going to multiply all coefficients and remember, coefficients are the numbers in front of the variables. And the second thing that we're going to write down on our notes is we're going to add the exponents. And hopefully we all remember from 7th grade math that powers are exponents. So even though we have two different vocabulary terms, they mean the same thing. A power is an exponent and the exponent is a power. So if I had an example such as 3a to the third, or 3a cubed, the 3 would be my coefficient, the a would be my base, and the 3 would be my power or exponent. Now, I feel like it's a good time to go ahead and move on. Example A, we're going to go ahead and apply exactly what we wrote down. We're going to multiply our coefficients and we're going to add our exponents. Now, we're going to break this down step by step so that we can all become masters of this because it's so easy. We don't ever want to mess these up. Now, we actually have two coefficients. The first one is 21 and the second one is here. We can't see it, but we all know it's understood that if a variable is there without a coefficient, it's understood to be 1. So we're going to go ahead and we're going to write those out. 21 times 1. And now that we've written those out, we can follow up by listing our variables. Times c to the 6th power times c to the 7th power. Now all we've done in this step is to expand the information. And now we can go ahead and apply our product of powers. We're going to multiply the coefficients. So 21 times 1 is 21. And then what are we going to do with the exponents or powers? We're going to add them just like we wrote down. So the base is c, and 6 plus 7 is 13. This is the final answer to simplify this expression. One thing I want to go ahead and write down for you is this to help you remember. You write numbers first, followed by variables. So as you can see, when we expanded this, we went ahead and we wrote the numbers first, or coefficients, and then we took care of the variables. Another thing to notice is, even though we had two variables of c, so c to the 6th times c to the 7th, it's easy to remember to add the exponents, but sometimes we get confused when we see more than one variable of the same thing, and we want to do something mathematically, like add, subtract, multiply, or divide. But we actually keep the base. So for this part of the problem, or portion of the problem, we would keep the base, which is c, and add the exponents. 6 plus 7 is 13. Let's move forward to example B on the notes. Okay, I really would like for you to try it yourself by pausing the video and writing down what you think, so that when I do the work, you can compare. And this will really help you to memorize, especially if you make a mistake, because then you could correct that mistake and hopefully not make it again in the future. So please pause the video and try this one out. Okay, so we'll go ahead and start to work it together now. First, we're going to go ahead and expand the expression. So we would start by writing out the numbers, or the coefficients. So we have 8 times 3, followed by the variables. We have x to the 4th and x to the 1st power. There's a 1 there. And now that we've written this out, all we have to do is go and apply our laws. We're going to multiply the coefficients, so 8 times 3 is 24. We're going to keep the base of x, and we're going to add the exponents. 4 plus 1 is 5. Did you get that correct when you tried to work it? Hopefully so. Let's move on. We're going to go ahead and work C now. Even though D is here, just go ahead and block that out of your sight. Okay, so we're going to apply the rules. This one has more coefficients, more exponents, more bases. But we're going to apply the exact same rules or laws. We're going to first expand the problem by listing out all of our coefficients first. So we have 2 times negative 3. Next, we're going to follow by our variables. So first comes a in the alphabet, so that's the one we'll list first. We have a to the 4th. We have another a to the 3rd, and a third a here, and that's to the 1st. Now we can go back and list our b's. We have b squared and b cubed. And now that we have these expanded, it makes it really easy for us to go ahead and apply the laws of exponents. So for the coefficients, we're going to multiply those out. 2 times 2 is 4, times negative 3 is negative 12. Here, we'll need to keep the base of a. So we'll have a, and we'll need to add the exponents. 4 plus 3 is 7, plus 1 is 8. And now we can move on to the b's. So we'll keep the base of b, and we'll add the exponents. 2 plus 3 is 5. And that is the final answer. Let's move on to problem D. Problem D presents a special case. It's very special. And I'd like for you to write this down on your notes. Special case. Exponents outside of parentheses must be distributed to every coefficient and every exponent or power. Using multiplication only. To make more room, I'm going to go ahead and erase what I've written, and then we'll get started on this special case problem. Now, of course, we're going to need to distribute the 6 because it's outside of the parentheses. So we're going to distribute it to the coefficient. So that will be 2 to the 6th power. Now, there's actually a 1 coefficient there, and sometimes we think we need to add those because of what we've done on the previous problems. But since this exponent is outside of the parentheses and being distributed, we're actually going to multiply the 6 times the 1, and that's how we ended up with 2 to the 6th power. Now that we have done that, we're going to distribute this same 6 to x to the 1st power, and we would end up with x to the 6th power. Of course, we'll need to take our calculator and actually determine a value for 2 to the 6th power to get the final answer. So 2 to the 6th power is actually 64, and then we already had the x to the 6th power. So that would be our final answer. Let's go ahead and try another one. Okay? For problem E, it's just like the last one, so of course I'd like for you to pause the video and try it yourself before we work it together. Now, of course, this again is one of the special cases because there's an exponent outside of the set of parentheses. So we're going to go ahead and work this. We do have 3 different coefficients. There's a 1 in front of the A, a 1 in front of the B, and a 1 in front of the C. So we need to apply or distribute the 3 to all of those. So this would give us 1 to the 3rd power times 1 to the 3rd power times 1 to the 3rd power. Now we need to distribute it to the A times A to the 6th power, because remember we multiply B to the 12th power and C, which has an exponent of 1 that we can't see, to the 3rd power. And now that we have this expanded out, we can go ahead and multiply our coefficients. Now 1 to the 3rd power is just 1. 1 to the 3rd power is 1, And again, it's 1. So 1 times 1 times 1 is 1, followed by a to the 6th, b to the 12th, c to the 3rd. And we don't actually need to write this 1. It's understood to be there because it's in front of a coefficient. And that is the final answer for that problem. Now we're going to go ahead and go to the next one. We have a special case here, which we need to do first because it's inside the brackets. And if you remember back to PEMDAS, that means we have to go ahead and do something if something can be done there first. And there is something to be done, and again, it's a special case. So the negative in front of the y, what does that mean? It means that it's a -1 coefficient there. So we're going to expand this portion out first. We would have -1 to the 2nd power times y to the 4th power, since we have to multiply those. Now -1 squared means -1 times -1, and a negative times a negative, or if we forget that, we can always use Captain Jack Sparrow. A negative times a negative is a positive. So this is going to give us a +1 y to the 4th, or just y to the 4th, because we don't need to write the 1 there. So all of this inside of the parentheses gave us y to the 4th power. So now we have a different problem. We have 6b to the 4th y squared times y to the 4th. And now we can go ahead and apply our laws of exponents. Of course, there's a 1 in front of the y as the coefficient. So first, we're going to multiply out our coefficients. 6 times 1 times b to the 4th times y to the 2nd times y to the 4th. We've just expanded that out. And now we can multiply our exponents. So 6 times 1 is 6. We only have 1b, so it's going to stay b to the 4th. But we have 2 y's, which means we need to add those exponents. We keep the base and add 2 plus 4 to get 6. And this is our final answer. For the final problem in our notes, it's a little more difficult, but I want you to take a look at this and have experience with it so that if it comes up on the EOC, you'll know exactly what to do. Now we have a lot of exponents, 2 different special cases, and a 3rd special case. Now this problem is designed not only to test your algebra skills, but to also make you reach back and think about PEMDAS. If you notice here in the brackets, we have something that we can actually do, and that's to distribute the exponent of 2. So we must do that first before we distribute the outside, the most outer exponent. So we're going to apply this to everything, all the coefficients and all the exponents. So this will expand out to be 2 to the 2nd power times x to the 4th power times y to the 4th power. And 2 squared is 4, x to the 4th, y to the 4th. And that's all raised to the 4th power. So again, we'll need to go ahead and distribute the 4 now. As well as in the front parentheses, we have to distribute the 2. So let's go ahead and get started. All of the coefficients here are 1s. And any time we raise 1 to a power, we're going to always get 1. Now, in a previous problem, I did expand that out, but it's not necessary. I just wanted you to see the math behind why. So it's going to be 1 x to the 8th power, y to the 6th power, z to the 12th power, times 4 to the 4th power, x to the 16th power, y to the 16th power. And now that we've done this, everything else is multiplication. So these parentheses don't really need to be there anymore. Every single thing is multiplied. So we can go ahead and write in our multiplication symbols between everything. Now we're just going to list it out. 4 to the 4th power is something that can go ahead and be done in the calculator. That gives us 256. So 256 times 1 is 256. And then we have our x's. We have x to the 8th times x to the 16th. Then the y's, y to the 6th and y to the 16th. And then only one z, and that's z to the 12th. Now we can go ahead and finish out the problem. Okay, I've gone ahead and moved my page up. So now we have our coefficient 256. We're going to keep the base x, and we're going to need to add those exponents. 8 plus 16 is 24. We're going to keep the base y and add those exponents. 6 plus 16 is 22. And then followed by the z to the 12th. And this is our final answer. I've been noticing that the videos aren't going over as well as they should be because I have several students who are just watching the videos, and that's not enough. When you watch videos, you're actually supposed to be learning from the videos, so getting your brain involved. And this is supposed to be a brain, even though it looks like a cloud. We want the brain to be working. And so for me to make sure that that happens, I'm going to start to put practice problems at the end of every video that you'll need to turn in to me when you come to class the next day. So go ahead and take out a sheet of notebook paper. So do not write these practice problems in your journal. You need a sheet of notebook paper so that you can copy down the problems and actually try to apply what you've learned in the video. If you can't do anything, then that means you need to rewatch and learn, not just rewatch the video. Watching the video is not enough. You must learn also. So I'll go ahead and put the problems up now. You have only 3 problems to do. And I need to see all of the work on number 3. Number 1 and 2, once you figure out the answer, I want you to go back and plug that in and show me what you did to make sure that it was correct. Good luck. That concludes the video on product of powers. All videos are going to be placed from now on 3 different platforms. They're going to be in Safari Montage so that students on campus that have computer classes or access to a computer, they can watch them on campus. They're going to be on YouTube because some students are having problems watching the videos through Edmodo, and they're also going to be on Edmodo. Additionally, I will provide the link to where the original video was saved, so that if any problems occur, maybe, hopefully, all of these different outlets will take care of it.